Welcome to my presentation. In this presentation, let us try to solve system of linear equations using some more methods, using some known methods. Okay, let's say we have an example of this type. Let's say we want to solve 2x minus y. Let's say we have 2x minus y is equal to 0, and then negative x plus 2y is equal to 3. Let's call this as equation number 1. Let's call this as equation number 2. Okay, we will try to use the row graph and the column graph to demonstrate as to how we could represent this system of linear equations in the row graph and then column graph format. Okay, so let's start with the row graph first. Step number 1. We'll call this as the row graph, sometimes also called as the row picture. Okay, so in here we want to write the coefficient matrix for using the coefficients of x and y, and the way to do that is as follows. The coefficient of x in equation 1 is 2, the coefficient of y in equation 1 is -1, the constant number is 0. We'll come back and then write that. The coefficient of x in equation 2 is -1, and the coefficient of y in the second equation is 2. So this is our coefficient matrix, and then we want to multiply this by this variable matrix, which is xy. We can also call that as a vector of unknown quantities, is equal to 0, 0, 3, not comma, 0 and then 3 below that, and that is the vector of unknown quantity, vector of constant quantities. So this is of the form now as matrix A times matrix X is going to be equal to a constant, which is B. We want to find the values of this X matrix or X vector. Okay, so to do that, we're going to follow this process. We're going to take equation number 1. We'll call this as step 2. We're going to take equation number 1, which is of this format, isn't it? 2x minus y is equal to 0. Since we are looking at this row graph or row picture, we're going to then say we want to find the values of for corresponding values of x, we want to find the values of y as well. So if we were to rewrite 2x minus y equals to 0 in the standard form, we can write that as follows, isn't it? 2x is equal to y, or y is equal to 2x, y is equal to 2x. If I were to come back and then construct the table of values like that, and if I were to give values of x, we can find the corresponding values of y. X here is the independent variable and y is the dependent variable. Whenever x takes on certain values, the value of y changes. So in here, if the value of x is 0, the value of y is also 0. So therefore, the line is passing through the origin. That is the indication. Then, if x equals to 1, if value of x equals to 1, in this equation here, we are looking at this equation. Y is going to be equal to 2 times 1, which is equal to 2. And we can give as many points as we want, but 2 points are sufficient to be able to draw a straight line. Okay? Then we're going to look at the second equation and then do the similar thing. The second equation we have here is negative x plus 2y is equal to 3. Right? And if we want to write it in the standard format, we can write that as follows. 2y is equal to x plus 3, or I can also write this one as y is equal to x over 2 plus 3 over 2, like that. Now we want to look at that equation, and if we were to draw the table, or construct the table of values, we can give values of x and find the corresponding value of y. In this equation, y is equal to x over 2 plus, let me write this a bit more clear, x over 2 plus 3 over 2. In this equation, let us give some values. When x is -1, if we substitute the value of x as -1, -1 over 2 plus 3 over 2, that is going to be 2, the common denominator is 2, 3 minus 1 is 2, 2 divided by 2 will be equal to 1. So therefore, when x equals to -1, the value of y is positive 1. Again, we want to find one more value. When x equals to 3, since we have a positive 3 over 2, if value of x takes on a -3, -3 over 2, positive 3 over 2 cancels out, isn't it? So therefore, when x equals to 3, the value of y is going to go to 0. So let's pick these 2 points, and then let us see if we can plot these on a graph sheet. So what have we done here? We have taken the rows, the first row, and then this is the second row. This is the first equation and second equation. Since it is in a row format, we have taken that, and then we want to draw a graph out of that, and then we want to see how that looks, and if that gives us a solution point, that gives us a point of intersection or a solution for this system of linear equations. Let us see. So if I were to graph this one out, let's say this is my graph sheet, and let us say this is how it's going to look like. Okay, let me extend this some more. This is the origin, this is the positive x, this is the negative x, this is the positive y, and this is the negative y. So this is the origin, and then if I were to pick some points on the x-axis, 1, 2, 3, 4, 5, this is 1, 2, 3, 4, 5, 6, and so on. And on the negative x-axis, if I call this 1, 2, 3, 4, 5, 6, and so on, -1, -2, -3, -4, -5, -6, and on the y-axis, let's call these as 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. Let us plot these points, and then let us use different colors so that way we know what we're doing. So when in the first equation, when x equals to 0, the value of y equals to 0. Let us identify that. That is right at the origin there. Okay? And then the second point, when x equals to 1, the value of y is equal to 2. When x equals to 1, we go 1 unit on the x-axis and 2 units on the y-axis. 1, 2. So that is our second point. So 0, this is 0, 0, and this is 1, 2. And we can draw a straight line passing through these points, and this line here is a representation of equation 2x minus y is equal to 0. Then we'll come to the second equation, and then we will try to, since we already have the values of x and y in this table of in the construction table of values, we will plot them on the same graph sheet. When x equals to -1, the value of y is positive 1. When x equals to -1, the value of y is positive 1. So we go 1 unit to the left, 1 unit to the top. So therefore, that is our first point. This is -1, positive 1. And then the second point is when x equals to 3, when x equals to, oh, I should have said this should be negative 3. When x equals to negative 3, the value of y is equal to 0. Where is the value, where is negative 3? On the negative x-axis, 1, 2, 3 units. That is right there. There is no y ordinate to it. Therefore, that is the point we're looking at. This point here is negative 3 comma 0. That is the second point. So we have these 2 points, and now we want to connect these 2 points with a straight edge and then extend it all the way. And when we see that, when we do that, we see that the point of, when we draw it to scale, you'll see that this point is going to be that point, and when we project that point, let me use another ink here. These 2 lines are going to intersect at a point, and that point is the point, is the solution point. If you were to draw it to scale, and then if you were to if you use a straight edge, you will see that this point will, these 2 lines will exactly coincide at that particular point. And when we project that point onto the y-axis and project it onto the x-axis, we see that the x-ordinate is going to be equal to 1 and the y-ordinate is going to be equal to 2. Therefore, x equals to 1 and then y equals to 2 is the solution point. What is that solution telling us? The 1 comma 2 is a unique point in this, for this system of linear equations, which satisfies equation 1 and it satisfies equation 2 as well. By the way, this line here is a representation of negative x plus 2y is equal to 3. Okay? Then, this is what we call as the row graph or the row picture. So next, let us see how the column graph looks like. Let me write that here. This will be the next step. So we will call this one as the column graph. Or sometimes it is also called as the column picture. So in here, we know the equations. The equations what we have are these, isn't it? 2x minus y is equal to 0, and then minus x plus 2y is equal to 3. These are the 2 equations we have, and we also we can also write this out as follows. We can also write this one as follows. We can write this as x is the variable, and then I can take the coefficients for equations 1 and 2 and write it out, write as a matrix like this, 2, negative 1, like that, and then plus y, and then write the coefficients of y in this matrix format, negative 1, positive 2, like that, is equal to 0, 3. That is, we'll write that as a matrix as well. We want to find the values of x and y. We want to find the values of x and y. In the column, in the row graph, we've already seen the values of x and y. We have seen the solution point just now. The value of x is equal to 1 and the value of y is equal to 2. This is our solution point. We will plug those in here and then see how we can draw a column graph. So, using this information, if I were to plug it in here, I can write this as 1 times this matrix 2, negative 1, plus 2 times negative 1, 2, negative 1, 2 should give us 0, 3. Should give us 0, 3. So that is what we're looking for. Or we can also state that the algebra part of this equation is asking us the question, what linear combinations of columns will satisfy the right hand side 0, 3? And we have just seen from the algebra part, we have seen that when x equals to 1 and y is equal to 2, that satisfies the right hand side 0, 0, 3. So if you were to take 1 times 2 plus 2 times negative 1, that will be 0. And then 1 times negative 1 plus 2 times 2, negative 1 plus 4 will be equal to positive 3, and that satisfies that. So given that information, the geometry part, we can use geometry to visualize this, and we can draw the column graph now. We want to be able to see how we can mix this, how we can mix these columns to be able to arrive at 0, 3. If we are given values of x and y in this equation, we have seen that the values of x and y are 1 and 2. We will come up with a unique set of values for x and y, and the values of x and y here are 1 and 2. Therefore, the question we want to ask ourselves is how many parts of column 1 and how many parts of column 2 we should combine, so we will be able to get the right hand side of the matrix, which is 0, 3. So if we mix one part of column 1 with vector 2, negative 1, and two parts of column 2 vector, which has negative 1 and 2, that would give us the vector 0, 3 on the right hand side. So let us see how we can draw it out. Okay, so in here we're going to go to a graph sheet like this. We're going to go to a graph sheet like this and then draw it out. Okay, so let me draw this. This is the origin here, and let's pick some points. 1, 2, this will be negative 1, okay, and then 1, 2, 3, 4, 1, 2, 3, 4, and this is the origin 0, and then we'll have negative 1, negative 2, negative 3, like that. And on the y-axis, let's pick some more points. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Now, so in here, we're going to first identify the first column. Identify the first column, and I'm going to use these different colors now. In the first column, we have 2, negative 1. Let me call this as this is column 1. This is column 2. Column 1, I have 2, negative 1. That means I'm going to go 2 units on the positive x-axis and 1 unit down. So when we do that, that is the point. That is where we want to be. This is going to be 2, negative 1, like that. Okay. Then I'm going to represent the second number, the second column, which is negative 1, 2. The second number, the second column. Oh, let me draw this. From the origin, I'm going to then draw this line like that, and that is going to be a vector like that. And the second point is negative 1, 2. The second point is negative 1, 2. We go negative 1 on the negative x-axis and 2 units on the top. So that is going to be the point, and therefore we're going to join it with a line like that, and this is column 1 and this is column 2. Okay, so from now I'm going to go use another ring. From the column 1, this is column 1, from column 1 I'm going to start there. Let me use red here, that shows better than blue here. So this is my starting point, and then from here, if I wait to, if one part of column 1 plus 2 parts of column 2, when I add them, that should give me 0, 3, and on the final point on my graph should represent 0, 3. Okay, so let us see that. So in here, if I'm going to start to represent the 2 parts from the starting point, from the starting point here, which is 2 comma negative 1. So negative 1, 2, I'm going to move negative 1 means to the left 1 unit and 2 units to the top. So this is 1 unit, this is 2 units. So this is the first part. I'm going to just join it with a line for a minute, and then again that is one part. The second part would be I need to mix I need to locate negative 1 and 2 from this point on. Negative 1 would be moving to the left, and then 2 will be moving up 2 units, 1, 2. So moving up 2 units, so therefore that will be the point. So therefore from here, if I were to join this point, this final point should give me the coordinates, or should give me the coordinates for the final point, or it should give me the values of the right hand side of the matrix, and which is 0, 3. So here this is x is 0 and y is 3, and that is exactly what we have, and this is what is called the column graph. This is what is called the column graph, or sometimes also represented as the column picture. So in my next presentation we shall look at some more examples related to solving system of linear equations.